module on time series forecast error prepared by Professor Ahmed Tata, School of Business, George Mason University. In this module, we will see what are some different quantitative ways to characterize the quality of a forecast for a time series. So let's look at column C. Let's say the scenario that we're dealing with is demand forecasting in some kind of marketing application, let's say. So in column B, you can see you have weeks listed 1 through 10. And let's say that we are in week 1 and we actually experience a demand of 22. That's what you see in column C. Now, based on the demand that we experience in week 1, we'll make a forecast for week 2. For our purposes in this module, where we are discussing errors, it really doesn't matter what technique we use for the forecast. There are all kinds of sophisticated techniques you could use. You could use naive methods. You could ask around for friends. So for our purposes here, it really doesn't matter what method you use to do the forecast, just that you have made a forecast. So let's say in this case, I will be lazy and naive, meaning I will take this week's demand and that will be my forecast for the second week. So for week 2, my forecast would be 22 units. So you can see there's a 22 units forecast for week 2. So then week 2 comes around and we actually experience the demand. So, and it turns out that the actual demand in week 2 was 18. So obviously I have overestimated by 4 units. Okay. Similarly, now I have the demand history for 2 weeks, 22 units and 18 units, and I would use that to forecast for week 3. And again, if I use this naive approach where this week's demand is my forecast for the subsequent week, then my forecast for week 3 would be 18 units. Okay, and so it goes. So using the naive method, my forecast for for each week would be, for the next week, would be the actual demand experienced this current week. So if we follow this method, so I've shaded these columns out for you deliberately so that you don't look ahead. So you can see I have in column C, the numbers in column C are the actual demands, and the numbers in column D are the forecasted values for those demands. Okay, so as you would expect, sometimes you would over forecast, sometimes you would under forecast. Okay, so the forecast error that I have abbreviated as FE in column E is simply defined as the actual value minus the forecasted value. So this is the actual value, 18 units, minus the forecasted value, which is minus 4. So it's I overestimated by 4 units. Okay, so you can do this calculation for all the periods. I copy that formula down for the remaining periods and I get the forecast errors. Okay, so in the chart that you see on the right hand side, the actual demand and the forecasted demand are shown as two graphs, one in blue and one in red. Okay, and you can see that the forecast is a little bit off. So there you have the forecast error. So now you've seen the forecast errors for each period. How can we somehow summarize what is the quality of this forecast overall for all these periods in this exercise? So there are different metrics that one could use. Obviously, I simply can't take the average of the errors, because since sometimes I'm over forecasting, sometimes I'm under forecasting, if I add them up, they'll tend to balance each other out, and it will appear as if I've done a very good job of forecasting, because my average forecast error would be 0. So to get around that problem, one of the ways you can do it is to square the forecasting errors, the same sort of idea that you did, that we had when we computed variance and things like that. Okay, so FE squared is simply the square of the forecast error. So here we go, is equal to minus 4 times minus 4. So there's the squared forecast error. And I do the same for all the remaining periods. And to get some kind of an average, okay, so I just add these squares up. Okay, and I take the average. So what should I divide by? I should divide by 11, because I have made forecasts for 11 periods. So here's my first forecast, second, third, fourth, fifth, sixth, seventh, 8, 9. Oh, I should divide by 9. I'm sorry. There are 9 periods for which I made a forecast. So equal to 137 divided by 9. So this value 15.22, is what is called the mean square error, MSE, that you can see that I've written the abbreviation over here. So let me write the term MSE right below it. So that's one way to characterize the quality of the forecast. The smaller the mean square error, the better the forecast, of course. Now, there's another way to quantify the error, of course, and that's to what's called the absolute error. So it's basically you have to get rid of the sign. So I use the built-in function in Excel called abs, absolute value, and I take the absolute value of the forecast error. Okay, and I do that for all the periods in which I have made a forecast. I add them up. So on average, what has been my error? It is simply 31, once again divided by 9, because I've made forecasts for 9 periods. So this value of 3.44 is what is called the mean absolute error, MAE. Okay, so either one of these two metrics would give you a sense of how close the forecast was, okay, on average. And the smaller the value of MSE, smaller the value of MAE, the better the quality of the forecast, at least numerically in terms of accuracy. Now, one thing you can see that both MSE and MAE depend on the units for the measurement. So if the demand was in kilograms, then it would be in kilograms or kilograms squared. If it's in liters, then it depends on the units. Okay, so get rid of the units. Typically, you can do percentages. So this is the percentage forecast error. This is simply equal to the forecast error, the absolute value of the forecast error, divided by the demand, the true value, the observed value. So I made an error of 4 units and the actual demand was 18. So I divided by 18. So this is the proportional error. Okay. So I do this same for all the remaining periods, sum it up, and divide this by 9. So this 16% that we just got, 0.168, 16.8%, the name for it is mean absolute percentage error. So you can write this as 16.8% instead of 0.168. This MAPE, mean absolute percentage error, that also gives you an indication of how good or bad the forecast has been. But the important thing about MAPE is that it is unit independent. You have normalized it for whatever units was used in the time series. So these are 3 very common metrics that are used to characterize forecast error, and the smaller the values for these error metrics, the better the quality of your forecast in terms of accuracy. There are many other aspects to the quality of a forecast, but at least numerically, in terms of how accurate it is, these 3 are very common metrics that are used to quantify the accuracy of the forecast.